Now, thanks to Jasna, I know almost all of you are chemists, and that's scaring me, to be honest, because I'm not a chemist, so you can always ask me questions I cannot answer. Originally, I wanted to speak a lot because I'm the last one, no time limit, nothing, so I can keep you here as long as I want. But now I know you are chemists, so I dropped half of the presentation. Who wants you to ask questions? Not me. So that will be short and hopefully easy to digest. And this is my next one. Yeah, so this is my reduced agenda for today. First, I'd like to show you a problem and with a real life example for that problem. And then choose a solution, of course, surprisingly a tool from ChemAxon, which helps us to solve that problem. And then look inside into the tool, how it works, and of course the speed of the tool. And I will show at the end how easy to start with that tool. So the problem is very easy. It's just the search. It's just one word. Those numbers you can see here are coming from the internet, but from white papers, for instance, from Google white papers. And it tells that 5 users in average we spent on searching a week. That's, yeah, could be more or less, but even 5 hours is a lot. And of course, it's included not just finding the papers you are looking for or the documents, but finding the information within the documents, which can be a lot of time if, for instance, we are talking about a long patent. So that means it could be $250 a week what we spent on searching and, let's say, losing. And if we extend it to 100 users and 1 year, that's very scary. $1.3 million could be what the search could cost us. But what if we had a tool which can save us only 1 hour a week on the search task? Sorry. Also, again, extend it to 100 users, and for 1 year, that could save us a lot of money, $240,000. Of course, they are just imagined or just estimated values. But for instance, a tool like this one I will speak about will cost only 1 month of the savings, so the return on investment is very, very fast. And the example to prove that is true, what I would like to show, is a conference which happened last year. I try to page sometimes. I'm successful, okay. So there was a conference with 40 different presentations with 1,000 slides. And let's imagine that maybe 2 weeks later, a colleague asks you asks you about something, a specific topic, a structure or something he's working with, and you remember you have seen it on the conference. So one solution, you start send all the presentations over to colleagues, so that's their problem. Or you start searching the presentations and find that particular structure what he asked for. And that could eat up a lot of time. In this case, if 2 seconds what you spend on every slide, which is also an estimation, could eat up half an hour. But with a computer-supported method, this is the guy we are looking for. With a computer-supported method, it could be 149 milliseconds. And the trick behind is not that hard to understand. We have a lot of tools to search structured information, which is stored, for instance, in a relational database. So one obvious choice to try to make the unstructured information, which are usually the presentations are. So let's try to somehow make them structured. And the trick, yeah, it is easy to think about it and maybe easy to find a way, but it's not easy in practice because, for instance, this particular guy has a lot of synonyms, and they are just the just the textual representations of the same structure what I showed on the previous slide. And there are a lot more, for instance, Excel files, OLE objects, so on, scanned documents, images, a lot of different possibilities. So in practice, it's not that easy anymore. But in this tool, in the ChemLocator, we can do that. I will show how, but I would like to introduce the ChemLocator to you first. That tool is a web-based search tool to find chemistry in unstructured data. So I mentioned the unstructured data a few times today. So let me clarify. The unstructured data is everything which has no predefined data model or not organized in a, let's say, predefined way, according to Wikipedia. And it's also very important to tell what we are not doing. We are not a content management system because we don't store documents at all. So you don't need to move any of your documents to specific ChemAxon store or something. And this is why we are not content management system, because usually, traditionally, it stores the document maybe with versioning, provides a search interface, and this is what we are not doing in ChemLocator. But we can fit into in enterprise content management system because that provides a lot of different systems which have different responsibilities, and maybe one system is searching all these possibilities, and that could be a ChemLocator. So just again, what we do, we only connect to your repositories, and we don't copy your documents anywhere. We just connect there, read there, and try to extract all the chemical and free text information from them. But let me highlight the cloud type of storages what we support, because I think here we have a cool and more or less unique feature, is that we not only connect to these cloud drives, but we also respect all the permissions set for the documents there. So we handle the document permissions even in the cloud drives. And let me show what we support. From ChemLocator, we have two different editions. One is the personal and one is the server edition. They are very similar to each other, but the personal edition works very well for individuals or maybe small companies, and it lacks of a few features what we have in server edition, for instance, the security handling and the business cloud subscriptions like Google Apps for Work and OneDrive for Business. And the server edition, as you could see, the logs in the rows, we support a lot of options to the security as well, what can be implemented in OneDrive for Business, for instance. So take a look inside how we work. Sorry, I was a bit surprised that there is a small icon there. So how we work, yeah. We have a Windows service which runs obviously on Windows machines. On the top of that we have a REST API. So probably if you don't have a Windows environment or you have an application which is not running on Windows, you can still use the REST API to connect that. So that's good for integrating with other tools. We have an authentication layer, which is, for instance, not part of the personal edition, but it is a component-based something, so you can extend. If at the moment we support Active Directory, but it's component-based, so it could be extended with any kind of authentication. We have two engines running under the hood. One is the free text search engine, and the second one is the chemical search engine, and still have the opportunity to extend these engines. Both engines are, let's show what we do. So both engines are working on the same content sources. So it could be a cloud or it could be local file system. And what we do under the hood for the free text, of course we do free text indexing, so you can search the documents with free text and also index the metadatas. And we also have an automatic tagging system which helps you a little bit to categorize the documents. They could be refined after the indexing if the automatic ones are not fit for you. And in the chemical search engine we have almost everything what, for instance, Daniel presented here. And this is why I'm a bit glad that he was before me, because it's easier to understand now what ChemLocator is all about. So we use the document to structure Under the hood, we have also a component which is working with Office files, for instance, JChem for Office, or from other providers. Yeah, we have a chemical file extractor which works on chemical files, but we can interpret corporate IDs and also recognizing images. I mean, text or structures on images as well. It could be extended. For instance, we created 3 integration or extensions to the search system. One is working with the ChemAxon's compound registration. Second is searching for compliance information for structures, and we also support an ontology search for the free text search. And the last layer, let's say, security trimming, which works in the query time, and that will filter out all the documents the user does not have access to. And I mentioned at the example when I started to introduce the ChemLocator, this very fast searching speed, 149 milliseconds, and this is the evidence for that. It could be done. So we are looking for that guy, convert it to a structure, and searching for that. We found quite easily the presentation from that conference. And if you see here, we didn't find the word what we were looking for, but we found a synonym for that word. And here you can see the total query time. Yeah, here this is the amount what I mentioned, but it's a quite how to say light example, because this system contained only the few files from the example. So we can extend it a little bit more. There is another performance test what we did. It worked on the local drive with 60 gigabytes of data, 120,000 documents, and almost 3 million structures in it. A very general search condition, for instance, for benzene could take a lot. Oh, I forgot to tell, the vertical axis is the speed, search time, and the horizontal axis is the documents returned, for instance, from 0 to 10 and so on. So if you search something very general, then and you ask for 10,000 hits, then it can be 4 seconds. But for instance, if you have a bit more specific query condition, then having 1,000 hits is somewhere around 300 milliseconds only, which is quite fast. And that was done only on one server, so there is no scaling included in this example. And the last topic, how easy to use, is to show how easy to use the ChemLocator is the deployment. As you can see here, I mentioned we have 2 different editions, server and personal. They share the same install process. So we have one installer, which is an exe file, and that provides a wizard. So that's a wizard-based installer. It will really not require any IT support, because there is a wizard and with 7 steps. And then if you completed those steps, then you are ready to do. You're ready to go. That's complete. As I mentioned, you can start using it after you completed the wizard. So I think if you go outside, you take a look at the screensaver or demo machines, you will see in action. I mean, a video. It was 1.5 minutes to start from the beginning of the installation to have it ready on the computer. So the take-home message from me today is that ChemLocator is a web-based hybrid search tool combining free text and chemical search, which supports cloud together with the document permissions, so the permission handling. It works on your documents, so you don't need to move any of your documents. We will read that, and you won't need any IT to start with. And this is the team, and thank you for your attention. I'm still scared, but do you maybe have questions?
I suppose the service is running in the background when any file is changed, it's re-indexed.
Yeah, it is running in the background, but we have 2 different kind of indexing process. One is the full indexing, which somewhat similar to who knows SharePoint, which is implemented in SharePoint. The full indexing means that it will drop everything which is already indexed, and it will start from scratch. But we have also the incremental indexing, which will only take into consideration the changes which happened since the last index. It doesn't matter which type of index happened previously, but it compares to that.
So my question is, what happens often is that the documents themselves might not change, but their location might change due to, I don't know, moving files around, reshuffling the structure of the folders, and it would be a waste of resources to re-index everything because just the file moved. So do you keep track of the file identity regardless of its exact relative path, for example?
No, in this case, if you move a file, that would mean a delete and an add. So we will recognize that something is deleted, and at the other place it is added. So it will reprocessed.
So wouldn't it be possible to add something like an MD5 hash to recognize that this file has actually been indexed before and the chemical knowledge has been extracted? Because sometimes the chemical knowledge extracted might have been corrected by by a chemist, and you wouldn't want to re-index something that has been verified already.
Yeah.
So, and the document itself has not changed at all.
Yeah,
so
yeah.
I think in many scenarios, from my experience, this would be useful to keep track of unchanged files but just moved files.
Mm-hmm. Yeah, you are totally right, and we were thinking about it in the past. But at the moment, the problem is that the indexing needs a lot of resource. And if you have a lot of data, then it needs a lot of resource, and we try to minimize the task what we do during the indexing. So we sacrificed it right now, but maybe it will come in the future. I cannot say any closer right now.